Okay, so before the break, we started into course policies, just a rough preview. Today's sort of preview day, seeing what's going on. I don't want to go over like what the first assignments will be, kind of start looking at the game engine we're going to use this class. So let's see. We can close out this one. That was just starting one earlier, just to show how quickly it started up. But there's no installers, so you can just download those files. So probably unzip the folder and move it maybe someplace other than the downloads folder, someplace that's less likely to get deleted. I'm just going to put this over in documents. And we'll want the one that does not say console be the Godot engine that we'll be using this time. So we're using the Godot engine, but this class is game development in general. So we're going to be looking at things in a more conceptual and generalized manner, and this is just where we're getting the practice with them. We have similar stuff available in all of our game engines. The biggest thing is some game engines, like Unreal, would have the same functionality, but they would have, like the rendering pipelines, their shaders are better. That's really what it is. Otherwise, they're moving at 140 frames per second. Oh, there was research released last week, came out on Friday. With VR, they extensive testing has shown that 120 frames per second is best for VR, which is slower than what we've been doing using on screens lately. So, yeah, some computer scientists sat down and did proper research, thorough research, repeatable experiments, and all that, and have said that 120 frames per second seems best for VR. So we're actually going down frame rates. Looks like we need to go down frame rates in some cases, but all our game engines are probably going to move at 140 frames per second, or be at least where we have control over it. And when we say 140 frames per second, that does not mean that it just divides the second up into 140 times. Early game engines tried to do that, and it gets to be problematic, actually, because some frames might need more than that. And if you run out of time to run all your code, there's nothing to do but crash. Other frames might need a lot less than that, right? What is function in the calculator? Open the calculator. We got 1,000 milliseconds per second, and we're doing 140 frames, so it's like 7 milliseconds per frame. But what if all of our frames only need 2 milliseconds? That means for 5 milliseconds, every frame is just stationary. That's where games start to seem jumpy, because there's more not moving than actual moving. So hard coding that number in became problematic. So when we say 140 frames per second, that's a goal of the game engine. It'll give some frames more time, some frames less time, and it'll do its best to average to that rate that we say. And then we don't get sudden crashes because we ran out of time to run the code for a particularly busy frame, or we don't get that laggy jumpiness because there's more not doing anything than doing stuff over and over and over again. So let's take a look at a first example. So create a new project.
Out of curiosity, that study about the 120 frames, was that just like after that point, there's no perceivable difference, or?
After that point, the nausea increases. The nausea and disorientation increases.
So it's probably because the brain is having to translate.
Overstimulation. I guess looking at a screen is different. Our brain, that's outside, so our brain focuses differently. Plus, remember, there is
empty space, not doing the things.
Right? Yes, and there are gender differences between and viewing graphics.
Really?
Yes, that's why for years it was. There are measurable gender differences. Somebody went through HRT therapy, and then one day it's like, wait, why did the graphics suddenly drop in quality? And started questioning it, or why did the graphics suddenly look different? And the other developers on the team were like, what's it doing? I described it, and suddenly all the men were like, men or women, or whichever one it was like, that's normal. That's what it always looks like. And then they started asking other people, and the way the death is perceived is in human dimorphism somewhere. So it just that one's been around that's been known for about 10, 15 years. But women look more at shadows and men look at the parallax. Well, so the graphics look different, but there are gender differences, so it could be somewhere in there, even in and out. But it talked about
Also, just generally, some people are better at dealing with VR than, just.
Yeah, the nausea, right? The reason it took back up when somebody thought of teleportation. It's like, what about if instead of trying to walk without moving our feet, we just teleport from place to place and then stop making people sick? Motion sickness. But the 120 frames were related to that. But that one just came out last week, so there's probably more to follow.
Oh yeah, there's gonna be a whole lot. Just double checking that, make sure that's good.
I was mostly mentioning it today while we're in preview mode to let you all know that I'm trying to stay up on research and stuff, and we'll keep an eye on it.
This 120 is kind of, because the difference between a screen versus not a screen is your brain. When it's a VR, your brain accepts that as reality, effectively, because that's the only thing it's perceiving. And so I'm wondering if 120 naturally lines up with most people's processing speed visually.
Perhaps.
If that's like around the rate that a normal human kind of like processes what's going on, and the difference between a screen is your brain is viewing it as not reality.
Yeah, that's taking
it sees it as a different object, maybe.
That's getting into the follow-up. So this was proper formal research. They have a huge collection of data, and the when you plot the data on a graph, it's very evident which numbers stands out as best. But yeah, I was thinking about a screen that's external, right? Our brain has that sensory overload thing. We don't process all the information, so it might ignore some of those frames.
There are those that swear by the different frame rates. Those might be people that are better adapted or have done it long enough. Their brains done whatever, or who knows? But yeah.
There's different things, but yeah, it probably has to do something with the screen pressed up against your eye. It behaves different, but more to come on that. I will keep an eye on it. So let's jump into start working on another engine. So we have this discussion board. I like to do this in all the programming classes. Instead of writing a paragraph about yourself, it's by the time you get to this point in college, I know you know how to write a paragraph. Let's write a program that introduces you. So give it some sort of useful new project, a useful name. We'll browse, create a new folder for it. Right click new folder. I'll just give it the same name. Oh. Create folder up here. There used to be a checkbox here. I don't know where. Oh, there it is. Click the folder that says create folder. That way it gives it the same name. Makes it a lot easier to keep track of things. Unless there's a good reason to not keep track of that, right? You might want to have version 1, alternative versions, that sort of thing, which is better done with version control, but we won't get too deeply into version control. And then forward compatibility probably worked for most everything here. Really, actually, for everything we're going to cover here, we're looking at more of the concepts of game development so that you can take them to Unity and Unreal and GDevelop and Game Maker and all JMonkey and bless you, and so many game engines out there, or develop your own custom game engine. Right? We want to see those concepts. We're just using Godot to look at those concepts. So this is what it starts off. You can see it looks like a big 3D space. We'll see this pretty soon. The default for Godot 4 now is pretty much an open world 3D game. In those summer camps, when I have a week with middle schoolers, some of them have never programmed before, we had the 3D open world game going. Pretty much just using the defaults in the engine here. 2D is really easy. Terminology we use is everything is a node. It's set up in a tree structure. For those who have had a programming class where you talk about data structures, everything is a tree. So somewhere we need set up as a tree. We call them all scenes. So everything we put in the game is a node. And when we combine several nodes together, that creates a scene. And then we can put scenes can become a node in another scene. So those are the three terminology, but really scene means tree, what we would think of as a tree. So when we start diagramming it, things that looks like this, we have our root up at the top, or the parent, and then we have children coming off of that. And some of those have other ones coming down, and a big tree structure that looks like this. Everything's a node. When we get that whole tree, we call it a scene together, then that can be a node in another scene altogether. So we're building up scenes out of nodes, putting them together, and then we'll use the word scene differently again. So calling it a scene is what Godot calls it. For those who have had data structures in other programming courses, it is a tree data structure. Oriented slightly, instead of the spread out view, kind of rotate everything so that to make it fit on the screen with the indented ones. So we have I'll redo this picture. So the root, and then inside of that, there's another root, and then it has all of these things. So it has like 3 main nodes. And instead of the spread out version, we do more of the vertical version because that fits in a lot smaller space. So that's how we read what the pieces we're working with look like. So everything will start with everything we put in here is a node. And I have a video I'm going to send after we finish the lecture today that has it's a 42-minute video, but I think I watched it at double speed and the guy talks slow enough to follow it. It's not a follow along tutorial, but he talks about every node that is available in Godot. 210 of them. So it's not a follow along tutorial. In 42 minutes, he talks about all 210 nodes we have at our disposal in this game engine. And I watched it at increased speed. So I'm going to send that out, just sort of watch, see what's there, and maybe later reference. Help me keep track of what's going on and what. So we can do either a 3D scene. I didn't mean to do that. Let me delete that. For our first one, a 2D scene will work. You can do a 3D scene too. We have 3D stuff, but this is more of a traditional program. We just need some text output, right, for an introduction. So I'm going to do a 2D scene. You can see the blue line for where our screen size is. We'll see how to edit that soon. We're really in preview mode today. We double click and rename all this. So this is our UI. I'll call it that. So this is the area we have for our UI, the base root. I guess root might have been a better name, UI root, or I'll just keep it UI. And then we need to add child nodes to it, and we'll do something. So let's add for text. It's a fuzzy finder, so it's not Control F where it has to be an exact match. Start looking for something, it'll pull up what's close to that. You'll see the screen color node. Notice that 2D node we put in was blue. Things are color coded. So the text stuff we use on the HUDs eventually is all going to be green nodes. So we have rich text label. Text edit is for inputs. A button, progress, or just a rectangle so we can start drawing our own picture. Lots of different things. We probably want the rich text label because we're just, for a discussion board, we're just making some output here. Spread this around. And that's the top left. That's what's known as the hierarchy thing. So we'll go through our class examples, or I'll say over in the hierarchy, and that's referring to this box in the top left by the default layout. We can change that up, obviously. The one labeled scene, and notice how it's, we only have two things there, but you can kind of see the indenting there for that tree structure. The hierarchical tree structure is starting to form. Might want to give this a good, useful name so we can refer to it in our script. I'll just call this output. That makes it nice and easy to keep track of. Surely in this case, we just want a place to put some words, and we'll do most of the stuff with the script. Down at the bottom is file system. So a file explorer, but it's kind of restricted to this project. So the top level we're looking at here is that folder we created when we made the project. We'll see that stuff in greater detail. When we import stuff, that's the little tab up there. We'll see that when we're ready to do that, when we get to it. But we'll spend a lot of time in the hierarchy. Obviously, the editor is we're dragging things around. And then over in the inspector panel. And the inspector panel is where we will spend most of our time. This is everything. Well, right now that rich text label is selected. So this is everything about the rich text label. If I hover this, notice it's got this property here. Property gives it a name. Notice how it's spelled. It's spelled BB code _ enabled, but up over here on the UI, it shows some capitalization there and a space instead of an underscore. Those aren't very related. We'll see that soon. The text property is very, obviously something useful. Let's do our normal configuration check first. I'm just going to print the word, put hello world in there. If we can make the words hello world show up on the screen, then we know everything's configured correctly. And that way we don't waste a bunch of time doing stuff when we have configurations off. But all of these are properties that we can access from the script. And when we add new properties in the script, they show up in the inspector panel. We spend most of our time in the inspector panel on the user interface. And you can see it's very, very long. All this stuff is collapsed, and it grows dynamically. It changes as we add things to the script. They show up here, and all of these things are accessible from the script. We'll get there soon. Next to that is like nodes. So this is the properties that relate to the how the node interacts with other nodes. So when we send signals, different ways we have to send signals to other nodes, or different ways that other nodes have to send signals to our node. So that tab that says node interacts with other ones. History is all the things we've changed. We'll see about dealing with that at some point. Right, here's everything that we changed on this node in the order that we did it in, so we can see what that is. I'm not going to click this, but if I come over to, well, we'll see it later. Remember how we said that we were going to use Git version control? If we turn that on, then that shows up here as well. So all of our version control stuff. I'm guessing everybody's probably at least seen GitHub somewhere along the way, right? So a website that uses the Git protocols. The Git is built into the interface, so that shows up right over here. So we have our version control on a tab in there. We won't dig much into that, but we'll at least see where it is before long. The inspector and the hierarchy is where we spend most of our time in all of our big game engines. Let's run this, see if this works. So I put hello world there. There's this overall run button. This runs the game, right, starting from level 1, or the cutscene that introduces level 1 to the end. So if I hit this, notice it says haven't chose a main scene yet. We don't have a main scene. Don't know where to start at. If you come over this fourth one, third from the right, it looks like the little clapboard, traditional Hollywood clapboard thing. That runs the current scene. So if we click that, it'll run the one we're looking at. We should probably save this first though. Oh yes, for those in the classroom, I think several people already did already. It can be useful to log on to the Zoom call because examples here are code. Yeah, I only have so many Zoom buttons. When we get to writing code, I can zoom in on the codes. The code I can write really big, but we are following examples of text files, so it can be useful to log into the Zoom call if you have trouble seeing it. There's multiple TVs in the class though. So we use 2 nodes to create a scene. So I'm going to go ahead and save this scene. Save it. For this one, I'm just going to, it wanted to name it as what the root node was. So I'll just go with that. Organization goes a long way, but this is the only thing that's going to show up in this intro discussion board thing. So let's run current scene. We should see something. There's the words, looks like about the right spot. Kind of small, we can make them bigger. There's all that stuff here. So this is what you'll want to do this first week, first 2 weeks as we build those small applications, is instead of just jumping over to the internet and Googling, where's this button in Godot? Look through the list, see if you can find it. Because you want to get familiar with this stuff, right? And we have small applications to do the first couple of weeks, so take time to look around, right? Obviously, don't spend 6 hours looking for a button if you don't find it, right? If you don't find it in a few minutes, then maybe start Googling, but take time to look around, see what's there. That text is really small. So look through here, different sections, there's markup. It does accept markup languages. It uses, if anybody's a Linux user, it uses the same encoding scheme as your bash shell would. So like 33M for a color. Some of y'all might know what color that is, but has some words we can use. We'll get to that. Text selection, looking for size. Displayed text. Does that have size in it? I don't see a size there. You want to take a little bit of time to look around, see what's there.
This can be the problem. Sometimes stuff can be under tabs that you would never thought.
Yes. So size, color, font, those would be a theme, right? That's where this one happens to be.
Theme writer is theme.
A theme we put together a separate file and then bring into the theme. Oh yeah, so here's an example. I'm going to cancel out of this, but here's an example, right? So it's theme. When I click this, if I click this and then this, the inspector panel got bigger. So we can put together a theme, choose the font size here, save it, and that makes it like completely reusable.
Basically, you got like a HUD that's going to be doing a bunch of different text things.
You
make this, and then you can just call it up for all.
Yeah, exactly. Right. Or if you make a really awesome game and you think there's going to be a part 2 and part 3 and so on, you probably want to keep some things consistent, right? Oh, I didn't talk about scrolling. So scrolling, zooming in and out, I'm on the regular mouse, the laptop touchpad, and notice it zooms in and out to where your mouse is. So in 2D, that's sometimes the easiest way. It's the scroll wheel on a regular mouse. You can click on your mouse and click on the mouse wheel and do panning, but it'd also be a lot quicker just to zoom way out, move your mouse to the spot you want to go, and zoom in on that spot. You'll want to get used to the controls. So 2D, it's mostly zoom, panning, things like that. Is it alt scroll? Control scroll is panning if you're on a laptop with just a couple buttons. But I find it's a little bit quicker just to zoom into the spot you want. So theme overrides. So we could save a whole theme or go in the overrides, use the default, and we just need a different size. There's font size. Normal font, if I make the normal font 23, oh, it's still pretty small, maybe 32. There you go, that looks like it'll fit a little bit better on the screen. And yeah, for starting off, the first couple assignments are small to take time to click around the engine, and not memorize everything, but as you look for buttons, you're going to see other ones, and then later when you need those buttons that you just zipped right past on that first earlier, you might remember where they were. But there's also really good documentation on this and an excellent community of support. So plenty of places to find it online too. But first 2 weeks, the assignments are small so that you have time to click around instead of jumping right to online and Googling that one function, because then all you learn is that one function. All right, so the word showed up, but that's not the words we want for the discussion board. We need something a program that does an introduction. So I know at least one that was already submitted was done a little bit more than this. Somebody's worked with Godot before. Looks like they did 3D things. When I looked at the picture. So we have 3D labels. More is always acceptable. And when you see the instructions on the homework assignments, consider that the baseline. More is always acceptable. But this is all we need, just some little place to put out some text, and we'll have the program introduce us. So in order to do that, we need a script. So I'm going to come back up to this, the root node. In general, it's always good form, what we call a scene in Godot would be a prefab in Unity. We have different terms for them in different engines, but there's some sort of collection of these nodes is the basis of all the stuff we make in all of our game engines. It's good form that when we can to put the script on the root node. Sometimes it just doesn't make sense to do that, but this place the root will work. So there's up here in the top right, just about in the hierarchy panel, there's this little thing that looks like a piece of paper with plus sign. That's the add script button. So we click that, that's going to add a script to the panel we're on, to the node that is highlighted. GD script, it inherits from node 2D, which is just our basic node, which this one is just inheriting a blank script. When we get to like players pretty soon, player is already there. There's a default player script. When we're talking about physics and maybe build a quick car, there's a default car script that already takes certain things into consideration. So there's a lot of, we're not starting from scratch every time. Yeah, the default template is just blank. Sure, that name sounds good. And then .gd is the scripting name. So notice the scene, what we made here first, is UI.tcsn or TSCN. And .gd is our Godot script. And I put a note in the instructions earlier, I forgot to say when we looked at it, make sure you do not download the .NET version. .NET is C# syntax. it still compiles to C++. So it's like the Unity engine. We type in C#, but we run through a C++ compiler. And that one is not fully functional. It's got most of the stuff and they're adding more to it, but it's more like, I don't know, probably about 80%, only about 80% of the engine right now. So the C# isn't completely there. And they both are, whatever scripting we use, it runs through a C++ compiler. So I'm going to get rid of the comments. We don't need those. Those are just clutter and cool. We have a pretty nice IDE here to work with, actually. Our language is roughly based off Python, but it's going to go to a C++ compiler. So we don't really want to do dynamically type like Python. That's one of the things that makes that language slow is the computer has to take time to figure out what type of data we have and how much spot and RAM it needs to reserve for it and all of that. So it is extended that we have the option of using, making it a strictly typed language, which means we put in what type of data we have. So if we have an integer, we say int, and then the computer doesn't have to waste any time figuring out that the data we have is an integer and it needs 32 bits to store that. It just automatically reserves 32 bits in RAM. It makes it a lot faster. If we don't do that, we get what's called var type, variable type. It's just a default size that it uses in RAM. So RAM is not used efficiently, and over time it can start to make things run slower when games get big. So we want to do that. There are always two things that we have to do in pretty much all our game engines. We do a setup and then frame by frame. So there'll be one function for setting things up and then how we process through the frame. And there's different ways that we can do the process. We'll talk about this more later, but Godot here uses either graphics or physics priority. We'll talk about the parts of an engine soon, but do we want the graphics to have priority or do we want the physics engine to have priority? Which one's more important in our game? So underscore process gives it graphics priority, and another function, oops, process. Yes, function physics underscore process. Notice that delta, that'll be important. We'll see that soon. Those are our two ways we can choose frame by frame. Are the physics more important or are the graphics more important? And that's not a general question, right? That's very dependent on the game we're making. And in general, we're not going to see a difference until our game gets really big. And then to the point that if we're running 140 frames per second, sorry to punch that calculator, that we might run out of time in 7 milliseconds. And something needs dropped, right? If we give physics priority, then graphics will be dropped. So we'll get, right, that's one frame glitch of maybe somebody goes partway through a wall in order to handle all the physics processing and they're bouncing off the wall properly in the next frame. Versus graphics priority, the graphics are going to stop perfectly at that bound, but the bounce back from the wall might be a little bit off because we wanted the graphics on this frame to be perfect, and we sacrificed some of the physics calculation in order to get in that time. So you'll decide which one is more important each game. And really, it's not going to make a difference until your game gets big and complicated. Different game engines do that differently. What's that?
It's not gonna matter until it gets to the point where it's got lag, it's got to choose.
Yeah, different game engines handle that differently. So in Unity, you choose the point in time. So is it at the beginning of the frame, the middle of the frame, or the end of the frame? Or Unity also allows for a fixed point of time. So, but all of our game engines will have that basic thing. One function to start to set everything up, and then it runs one time, and another function that runs frame by frame by frame by frame. And we usually have multiple options on the frame by frame by frame. Let me add a bunch of lines here. I'm just gonna add a bunch of lines. See this over here, we have the file names, that's pretty obvious. When we come down, notice there's those function names we made. Those are links. So we've added all that white space, so when I click on it, it jumps right to that function. That can be really, really useful at times. I can zoom in on the text a little. Let me zoom in so this is bigger. So we have two things we need to do. We need to set stuff up, and then whatever's going to happen frame by frame. I think in this case, it's a program that's going to output some data points about me for like a brief introduction. I'm only going to do 3 or 4 for the example. I can't remember how many I put in the instructions, but you'll just add more data points, write longer sentences, but it's going to follow suit from this. So first thing we need is some data points about me to work with. You can use different formats, right? If you're in this class, you would have had to add at least 2 programming classes, right? So everybody's seen a little bit, about lists and arrays. Those nice and consolidated. We're putting words up to screen, so everything's going to be a string eventually. Might need to do some math with some of the data points about yourself or something, but to set things up, we use the keyword var to create we're going to create a variable. There's also constant, we'll get to that soon. But starting with var, we want to create a variable, give it some sort of name, something useful. I'll just put my name in here. That seems like a good one. And then a colon, and then the type, which is string. Oops. Make sure you choose the right thing off the predictive text list. So some sort of variable, give it the name, right? A variable is just a named location in memory, because the computer might decide that's RAM address 2309 and is 84 bits long. We'll never keep track of that. So a useful way to keep track of it. And then the data, by putting the type in there, it will make it faster. And that is something we definitely want in a game, right? Ready to punch it in the calculator. 140 frames per second is the standard starting point. We do get faster than that. But like I mentioned, that research just came out last week, said that 120 is ideal for VR and AR. Actually, it might have to do more with the AR. But they talk about nausea and stuff in there. It's more to come on that. But
There's a lot of stuff we're only just now figuring out, despite VR being around since the 50s.
because we got rid of it, yeah, because it made everybody sick. It's not motion sickness, it's full on nausea. People would throw up all over. Since the 50s, people have been throwing up on the expensive equipment. So in the
it wasn't that bad.
Yeah, in the 80s, they finally kind of gave up on it, and then it came back came back recently. They figured out how to stop. They're figuring out how to stop people from throwing up on it. It has a lot of advantages, but we'll see that's coming up. Then we need to give this a value, right? Everybody's seen some programming, so bookmarks will make it a string.
The variable name has already been used by something I haven't figured out yet, but it needs to be changed.
Yeah. It's small on the screen, but everybody see what he's reading. Remember, name, redefined, original. Oh, so there's apparently already something called name. Which is actually what's shown in the hierarchy here, right? That UI is the name. So we can't use a name. We can't use something that's already been used. So I'll just make that first name. The convention is snake case. So all lowercase letters with underscores. That's called snake case. That's the conventions in Godot. So it's helpful if we write our code the same way, and then our code matches what the engine's written in. So that's a little bit different than Python, right? Python would just be first name equals Chris, and then it handles all the others. But we need that strictly typed part. and do a couple more. So our age is usually given as an integer, so abbreviated as int, equals 45. We'll do a shortcut here on the next one. So town, which would be a string, right? So yeah. So everybody remember the reassignment operators, where if we already have something assigned, we can things like x equals x plus 1. That happens a lot in code. So we can abbreviate that, and that becomes x plus equals 1 is the same way of saying that statement. So it just combines our operation in one. We can do the same thing with that type. So colon is the type operation. Colon equals, which if you didn't hear him a second ago, that's referred to as the walrus operator. Looks like a walrus. Colon equals, so it's the that same shortcut for typing it. So the computer will figure out that's a type, which that happens at compile time, not at runtime. So we still, if we do it that way, we still get the speed advantage of the strictly typed language. And I live in Clarksville. Maybe one more bar. It's
The null equals still makes the computer figure it out, but it figures it out before it gets to the point where it will be a problem.
yes, it does. It does it before the speed comes into consideration, before the game even starts. So there's a few data points about me. Yours requires a few more, so like 12, and then we need to put them together in sentences. And to do that, we need this output thing, right? We saw that a minute ago. Output has this text property, so we need a way to access that. This was a really nice one in Godot 4. So if you click and drag over, that's the value we would assign a variable to. But we can do better than that too. That's been around for a while. A newer one that came out with Godot 4 last year is if you click, then hold Control and drag over to your script. Click, Control, and drag that. Oops. Which sometimes takes a couple tries.
All in ready?
Yes. Mine's not dragging right.
I just clicked dragged over, and once I was in Spin, I pressed and held Control until I let go.
Okay. Yeah. So yeah, sometimes I miss it. Usually with a real mouse, I don't have any trouble because then I have two different hands. But I find that on the touchpad, I have to use one hand to do Control and click, and then the other hand to drag. So I miss it on the laptop touchpad a lot. Real mouse makes a difference. I just forgot to bring one with me today. So add on ready. Notice our setup function is called ready. So see the connection ready. That's part of our setup. So when we're setting things up, create a variable called output. And that is $sign output is referring to this right here. So it's telling us exactly how to get that. And well, we know that is a rich text label, right? We know that's rich text label type, but this is an important one to use the walrus operator on. It's a whole lot easier just to let the compiler figure out what type it is, and then do the proper reservations of RAM and all that, so that we're efficient with our resources. And then output, well, we can see over in the inspector panel, output has this thing text, which that also drags in there. Actually, if we right click on that text, just copy value and copy property path. Copy value and come over here and paste it. Okay, and I copy it. Copy value. Paste it, gives us a string as text. I don't know why I'm not copying that. Copy. Paste. That does the same thing as this.
Is it property path? Is that what you need?
We actually want the property path. So now that we have a reference to the output, I'm going to refer to that here. So just a variable called output. So when this starts, I'm going to do output, then dot, and then that is what is here as the property path, or Control Shift C if you like the hotkeys. Copy property path, then paste that in right there. So output dot text. And this is why this right here is why gets categorized with Unreal and Unity. Because every word we need to write a script is already written on that interface. We just have to learn how to read it. So notice it's text formatted nicely. It put it in all uppercase letters. When I hover over it, it shows that it's actually something lowercase. So object-oriented stuff, right? Once we have that object dot anything over here, and we see that we can just reassign a value. Right? So we want to change that property of this output object, which was a rich text label, to some sentence. Do I have F strings here? I can't remember how they do the formatting. I'll just break it up in calculations.
Just double quotes and then
Oh yeah, the percent.
Then the letter.
Yeah.
So percent S, percent.
I'll come back to that. That's what I was thinking of Python syntax with the F strings.
Yeah.
That's much easier. We'll look at the fancy ones. Let's just do a simple concatenation for now, because hopefully you would have seen that in Python and SDEV 120 or 140. So what do we have first? The name. So first name plus lives in plus town. Plus period, make it a grammatically correct sentence. All right, just building a little sentence here. Like this software is going to do a little introduction for you. Not everything yet, but that's enough to do our first test, right? Always run a test every chance you get. Even if you've only written one line, if you've only written one line of code and you run a quick test and you hit a new bug, you know which line that bug has to be in. So now, as soon as this starts running, it should set up all of our references, all our data, create the reference to the thing that's on the screen, and change the text that shows in it. There we go. That's what the introductory discussion board is. So build up the sentences that way. Or take it a little bit further. Formatting's not difficult. It's not intuitive. It's not the same formatting as Python. Formatted string and good go. GD script format strings. That's pretty easy to find. They have great documentation. So it looks like this. We're waiting for %s, and then the %s is going to be the string that we want to type. So notice the variable, most of the string, and then we add in %s. We're going to add another string in afterwards. Then the actual string, format string, then that % again, and then the string that we're going to use to fill that in. There are lots of examples for that. That might be a good extension. I'm just going to do, I only have like 3 or 4 sentences, so I'll just concatenate them now like normal, but there's lots of expansions you all can do on this. Make it do a little bit more. More is always acceptable. The baseline instructions are just the baseline. Now we can add some more. So output text. I want to keep that old stuff, so I'll do the concatenate assignment. So plus equals, so the same as output text equals output text plus more stuff.
Yeah, I tried to do my first name is age and it's spat bad. No.
Yeah, that's what I was getting ready to do. So first
Can I say?
name. Yeah, I like to look at error messages. So y'all know what error messages is going to throw, right? Anybody that's typed in Python before has seen this many times. But I like to look at error messages because so often when we see tutorials and textbooks, we see that finished product where it's all cleaned up. That's not how it goes when we write code. So I like to actually look at the error message and learn how to interpret them and make sense of them.
Always the biggest headache because I started doing what I want to do and just like, oh God, write this stupid thing.
Yeah, like when we're following a tutorial and everything works perfect on their screen and we're just getting error message after error message and they don't tell us anything about fixing the errors. First name is plus age plus years old. Yeah, so you all know what error this is gonna throw. Not even gonna let me run it. Actually, it's gonna crash when I run it. There we go. So notice that when it crashed, it's still running. Right? It just paused. I still have a stop button here, but it automatically opened up debugging tools. There's all kinds of information. Invalid operands for string and int. The latest versions of Python have a clearer message there. The cannot concatenate a string to an integer. And this is based off Python, so the fix for that is almost the same.
Transmit integer into a string.
Yeah. But, notice I ignored all that stuff written in red, hit the run button, and that automatically opened up some debugging tools. It's actually a pretty nice IDE we have to work with here. Somebody spent a lot of time with that.
We're using VS Code now.
What's that?
I use VS Code with video.
Oh, yes, that works too. As long as you have if you want to use a different text editor, don't delete the console thing. So like VS Code would need that. And some other ones. The string, is it control click? So I held control and clicked on that word and noticed the documentation opened up. So instead of going and Googling it, you can just get right to the documentation that way. It's probably a better example we could use for that. Right click and close that. Or like process function. Control click, opens up the documentation right here. That can be really, really useful. See what the objects have. You'll want to do that a few times to kind of get used to things. Oh yeah, run a test, see if it fixed that error. It should have fixed it, yeah. But a new bug, wasn't a syntax error this time. Anybody remember the term for that type of error? Wasn't a syntax error. It wasn't, it's not a runtime error, it didn't crash. Syntax would be a compile error. Something's wrong with my algorithm, right? So I probably didn't want those jammed together like that. So that would be a logical error. Regular escape sequences will work. So \n for a new line, that's probably one you want. Or at least a space, right? Something was wrong with that. Something was wrong with that output. Either a space or a new line. New line's probably easier to read. You don't know the process. That one's called a logical error. I recently realized that people seem to never get asked that question after SDEV 120. It shows up in several SDEV 120 quizzes and then it doesn't get asked again the whole way through the curriculum. But it's important to remember that it's different words. So
I don't think I learned those error types until maybe when I took a job with last year.
See, I don't remember. Forgetting it, but I don't remember us really talking about error types that much, other than like, oh, we got a whatever while we were much of a focus on it in that first class.
It was like a mention of
Yeah, there's so, it's probably mentioned in passing.
Yeah.
And then never shows up again. That's why I was going to start working in some of those words, because those things are, right, expect to know some of that. And in the transition over the past couple of years to a couple 8-week classes, some of the focus, some things that were dropped, in particular vocabulary terms seems to have been dropped. So I'm going to start working that in. I guess that's like preview mode for the class. Expect lots of little words to show up and reminders about vocabulary and how to speak like a programmer. There we go. That's what you'll do for the discussion board. Just say some data points about you. Third person narrative is okay, because this isn't you talking, this is the program talking about you. So third person narrative works. Or if you want to, you put the pronouns in as variables. Make one of the variables a list of pronouns that you would go by, and then work those into sentences to make them flow nicely. But that's all you'll do for whatever the criteria were out there. And the assignments are the same way. They are the first 2 weeks. It's small programming assignments that you would have seen in the SDEV 1.1. It should be about that level, right? You're given some numbers, simple things, get some input. So the text input boxes, switches, sliders, all sorts of different inputs. You'll want to see what all they are. It's easy to Google, right? Inputs in Godot and input exam. Oh, they have great documentation. Their documentation has, especially for an open source project, usually open source is sparse if it exists at all, and written by somebody that is a really good coder, not a really good English speaker. Godot has gotten big enough that they have professional technical writers write their code. So it's not an afterthought. They followed suit from Amazon. The programmers don't write the documentation, a professional writer writes the documentation, which is very, very different, and then consults with the programmers.
We'll ask them, what the heck is this thing, what's to do?
Yes, PD script or C#. C# is still being integrated in there. They both run through C++ compilers. So it's not, the syntax is personal preference. Except that C# isn't fully integrated yet. About 80% now or so. It's coming.
Eventually it'll be a personal.
Coming along quickly, but C# is a proprietary Microsoft product, and Microsoft doesn't like to share. So that slows the process down a little bit. But the one based off Python, well, you'll see the differences very quickly, right? Instead of def, for define a function, we use func for our keyword, parameters, colon, indentation, all that stuff we're familiar with. Oh, that's not what I was looking for. UI buttons. So not inputs, I want UI inputs. And get out. Goes right to videos. Oh.
Inputs.
Custom GUI controls. There we go. Something like this, how to draw up. Oh, that's for making brand new ones that don't exist yet. User interface. This is probably it. Buttons, labels, line edits. Yeah, so we'll use some of these to make a little GUI for small, simple scripts, programs that the point of them is to get familiar with the game engine, the scripting language we're going to use. Start to use that a couple times on something easy, so that when we get to games, you already know a good bit of it. Check and see where the documentation is. Click around on the user interface, things like that. On Wednesday, we will go through an example that is similar to the homework assignments, but you could probably take it from here. So notice up here at the top, we have these tabs. So here's the asset store if you want to download something or buy something. it's open source. Most of their stuff's open source, but it's a store. They do still allow people to sell stuff. So better stuff often costs money, and we'll see how to sell our assets on there before the end of the semester. The script tab, the 3D tab, or the 2D tab. So 2D tab. So you'll probably be using either 2D or 3D depending on the game, and the script is the most often place you jump back and forth. The hierarchy and the inspector panel. That's where you're going to want to spend a lot of your time. Highlight the parent, right click, and add child node. And we'll keep looking for things. So like a button. We'll see an example of this, right? I'm just kind of previewing right now. If you wanted to add a button for, say, one of those homework assignment GUIs to click whenever you, after making the selections, there's the options on buttons. Check buttons, color picker buttons, menu buttons, option buttons, link buttons, and texture buttons. Texture refers to an image. So texture button is, you're gonna use your own image for the button. Slider. That's a good way to input numbers. You want a horizontal slider or a vertical slider. And you'll want to do a little bit of that. Clicking around to try and familiarize yourself with what we're going to use. This is where I always start with the game engine. Start with something small and simple to do all the randomly clicking around instead of trying to do that randomly clicking around and learning the scripting language while in a big complicated project. I learned that the hard way. I learned that after jumping right into game engines, and well, Unity is a great example. Was working on something, it was for school here, we were planning an event, you're gonna use Unity. So to see if something was possible, I just sat down with the stopwatch to see how far I could get in 4 hours. Jumped immediately into a great big huge project and was completely overwhelmed for about the first 2.5, 3 of those hours. And then it started coming along really quickly. It's like, okay, now I get it. This is all asleep from all those other things I've seen. And the classes on game development I've taken and stuff. But jumping in with something really hard right off the bat was overwhelming. So this is what I do when I start new game engines. Yeah, I learned that the hard way. Make a nice, subtle introduction. We can have multiple labels, right? Copy that. Paste that. Oh, notice this. 2 layers indented, so the second one is a child of the first one, so I'm going to drag that over. Now they're both child of the first one. We have multiple outputs, but only one of those is getting edited from the other side. Word wrap must be on. Kind of useful. That's a checkbox, right? So that's something we would come over here and just see if we could find a checkbox about word wrap. You may have to look around a little to find it. Fit content, scroll, active, following, auto wrap mode. That sounds like word wrap. So we can either do smart word wrapping, specific word wrapping, which means it's going to just cut things off. Well, not quite like arbitrary. It's going to do its best to find a space here. Smart word wrapping is the one we generally want, but arbitrary, probably not with this because it's going to just cut things off wherever. I guess it's going to line up. That one just happened to not line up nice. But adjust the word wrapping or turn the word wrapping off altogether. Wait, why did that not go off? Not the word wrapping. Fit content, scroll active, scroll following. It's an odd little one. Might be something y'all could look into. Do a good little, right, when questions show up, that's how we learn stuff. Ask a question, try to track down that answer. Actually, an easy solution once you see it, but that word wrapping one seemed like that should have wrapped, turning that to off would stop the words from wrapping. But still a word wrap on.
It's still trying to fit inside the box that is existing there somewhere.
Maybe you need to select another one, or does it apply to both?
You're on output two.
Yes.
Okay, so it was one.
You're messing with the one that isn't being edited.
Yes. So for those who haven't had me in class before, I like to show the error message, right? Not just that finished product. I prepare for things ahead of time. So now we got rid of that word wrap. You can't quite see everything. It's two goldfish. I'm not just two goldfish. Did y'all know goldfish live for a long, long time?
If you take care of them, yeah.
Yeah, I bought them in 2008 and did not think they'd still be around in 2024. No, 2007. No,
They also
2008.
get like 5 times bigger than anybody thinks they do.
Yeah, I got a couple. They're huge.
People think those little things in the fish, that is the smallest, like that is stunted.
Yeah.
Yeah.
But it's for a hydroponic garden, growing tomatoes and broccoli in my living room. That's when feeder supply and just asked for the feeders because they were really cheap. And those things live a long, long time.
My nephew's got some where they got them from feeder fish at some church program, and I don't remember what the original name was, but now they've changed the fish's name to Methuselah
Yeah.
because it just won't die.
They live a long time, and if they go out and end up in lakes, they just don't stop growing either.
Yeah, that's why they say to never put them in hay.
They just get bigger and bigger. They get massive.
Many aquatic animals will just keep growing until something kills them.
Okay, but sorry, that's a sidetrack. So yeah, I am also, that's another preview for class. I am very easily sidetracked. So yeah, there's that. Anybody have any questions about what that discussion board expectation is? Kind of make sense? Before I stop sharing the screen, and this is an active subject, we learn by doing. So that's what we're probably going to want to do the most, right? Is do stuff. So the class goes 1 to 4:50. So the general plan is we will talk till, this is probably going to be one of the longer days. And that was 3:30, that's an hour, 15 minutes, take a break, hour and 15 minutes. 2 of the traditional class length times, but then we still have an hour and 20 minutes that your schedule should be blocked off to learn game development. So please use that time productively. We're trying to have it every time. Basically, I will be sitting around, waiting for questions to come my way until 4:50. So my schedule is still blocked off for class. We're gonna wrap up here and then we'll call it lab time. Usually it'll be earlier than 3:30, probably closer to 3 most days. We'll talk for a little while, do some examples and stuff, do the whole class part, and then we'll break off for lecture time. There are 2 days I'm gonna be out of town. I have to go to summits for Ivy Tech. They're both in April. The consecutive weeks in April, so April 4th. 4th and 5th is the conference, but I'll be leaving a little bit earlier. I'll be leaving here probably like 1 o'clock or something to try to get through Indianapolis, because Indianapolis construction is still a mess and I only see it like once or twice a year. And I would prefer not to see it at rush hour and I have to get to Westfield. So I have to go all the way through Indianapolis. I don't know what the construction status is going to be like, but I'll probably leave Wednesday. So that day it'll be entirely lab day in class. And then the following Wednesday, Thursday, and Friday, there's another summit at French Lick. I'm just riding in the carpool. I'm not even driving that day, but we'll be leaving at 8 o'clock in the morning on Wednesday, so I won't be available. And then, yeah, I'll be at conferences and stuff in the hotel by the time that afternoon. So those 2 weeks in April, I'll be at, I have a project in mind around that time. So I'll have something for y'all to do, but we won't have lecture those 2 Wednesdays. But in general, we'll wrap up around 3 o'clock. And then have time to work on stuff. I'm getting ready to send you this link right here. Please watch this video at increased speed. Just preview stuff here. And don't try to memorize everything in this video, but quickly summarizing all the nodes we have available. All right, so let's get. What's that?
I was looking at the module 2 programming assignment, narcissistic numbers.
Makes sense.
Yeah, I thought it'd be way more difficult. It's just
No, it's a simple pattern.
yeah,
It's
it
that,
just looks intimidating.
Yeah, but it's a pattern thing, and computers are great at patterns, so that's why it makes a nice little programming thing. And it's kind of an interesting thing about numbers.
Can I spoil the answer? Well, kind of.
Yeah, it's not complicated. It's a high level math thing, but it's a pattern, and computers are great at patterns, so it makes a nice little.
Number equal to.
Yeah, so I just sent out this video. Check this out. You can watch it at increased speed. It just kind of summarizes all the nodes we have available, which obviously in some of our other big game engines, they might call them something different, might have a different name, might have something similar that's different, but there's a lot of consistency across them as well. So this will make a good introduction, even if you plan on every game you ever make, you plan on doing it Unreal. I mean, this will make a good introduction, and the concepts from here will translate directly over to that. Just need a much bigger computer to run that, and powerful GPUs and all of that stuff. But does anybody have any questions about that stuff today? And we were today was entirely preview mode. We will see all of that again. Wednesday will kind of be preview too. Right? We'll really dive in next week. But on Wednesday, we'll do a small example that's like what the homework assignment is. I'll give it a few seconds so people on Zoom have time to unmute and ask a question. Yes.
What do you mean by open world? Do you mean are we going to be using Perlin noise to create terrain and have like a 2D world where we just look around, or it's going to be like a 3D world within like an area?
Possibly. I wouldn't use Perlin noise for a terrain, but we will talk about what Perlin noise is.
I only use Perlin noise for 2D.
It would work. I use it for sky sometimes, and sometimes on water. But we'll talk about noise types. But at least a 3D world we can walk around. We're not restricted on which way we go. So more like a role-playing 3D thing where there's so much stuff to do, but it doesn't matter what order we do it in. That sort of openness. Not the continuously generating. But we might see continuously generating too. So continuously generating is not hard.
Did we see that in what you were doing? Graphics.
Oh,
Yeah.
no, continuously generating is like there's no world and it just forms as we walk around in it.
Yes, some sort of thing where it just spits out new stuff.
Yes.
Yeah.
The word for that would be procedurally generated. Open world is like an RPG. There's armor to get, and there's like magic spells we can learn, and it doesn't matter which order we do it in. The NPCs to talk to, we just wander around freely until everything's done.
Yeah.
But there's still a boundary to it.
The most famous one being Skyrim.
about?
There's quite a few of them.
2, 3.
All right, I assume it's been, more than 5 seconds, so I assume nobody on Zoom has any questions. Any other questions? I'll ask one more time. Okay, well, if you have any questions, let me know. Every day during our class, I'll just be sitting around till 4:50, except for those 2 days I'm gonna be at conferences. But I will have something for y'all to do then. Otherwise, we'll get back to it on Wednesday. Still kind of in preview mode for the class, and then next week we'll really jump in with the focus with language and physics and stuff next week. Wednesday, we will just jump in, continue with some simple examples. I'll see y'all Wednesday.